Yay! Hello there. I'm going to talk about optimizing life in Node.js. This is going to be a lightning talk for 10 minutes, so let's start. Who am I? I'm a principal systems engineer at Cloudflare. I'm a Node.js TSC member, and I'm the author of Ada URL Parser that's used in Cloudflare Workers, Node.js, Telegram, blah, blah, tons of other applications. So, some fun facts. On January 2021, I'm married with the love of my life. On June 2023, I made a little person called Ada, hence Ada URL Parser, and I contribute to OSS, which is like I have 300 commits on Node.js core. So how do I do all of those three things? I'm married, I have a kid, and I contribute to OSS. It's extremely hard thing to do if you are not optimizing for success. So some of my recent contributions to Node.js, I've developed Node Run, Node env-file for .env. I've implemented a env-URL can parse, and lots of performance improvements. So I'm here to share my secret sauce with you. This is my secret sauce. This changes from people to people. So I just wanted to share my perspective about optimizing my life and Node.js. So how did I do it? Are you familiar with OR gates? If A is true and B is true, A or B is true, and vice versa. So I'm going to talk about my marriage, then my kid, and then optimizing Node.js. It will be a three-part talk about my success path. So let's start with marriage, because that's the easiest part and most straightforward part of it. So let's look into the marriage logic. This is a really good slide from one of my heroes. Mary is my wife. If Yoz is wrong and Merve is right, then Merve is right. If Yoz is right and Merve is right, of course Merve is right. If Yoz is right and Merve is wrong, then Merve is right. If both of us are wrong, then Yoz is wrong. This is the marriage logic. This is my solution to happiness and hence optimizing for marriage. So how about our daily lives? Before diving into this, I told you that there's three parts of optimization. One of them is marriage, one of them is kids. Kids, I have literally no way of optimizing it. They're their own, and they have their own life, so I'm not going to dive into that. I couldn't solve that until now because I have a 15-month-old. Let's do that in 10 years, and maybe I will give some insights there. So this is a typical kitchen. We all have at home, I hope. And we always optimize for example, this kitchen has a sugar, it has a coffee next to it. This means that we are getting sugar and coffee every day. And we put it in a convenient place so that our happy path is always faster. But you realize that it's not always optimized. The sugar is bigger than coffee. It's technically impossible if you have a 2-to-1 ratio of sugar and coffee. So not everything is perfect. This perfect photo shows us that. So Node.js is not very well different than a kitchen. A lot has changed since the initial commit to Node.js in 2009. So let's dive into some of the details. One of them is TextDecoder. We all know how TextDecoder works. It takes an input of, when you initialize TextDecoder, it takes a UTF-8 or Latin1, blah, blah, all of those encoding types. Then you pass a uint8 array in order to decode it, and then it returns you a value. It should be simple as it is, right? But it's not. It actually takes more than the arguments that we use for. The first parameter can be 20, 30 different encoding types, UTF-8, UTF-16, little endian, big endian, blah, blah, other values. There's the ignore bomb value. There's a fatal value. I'm not going to dive into the details, but the surface of the implementation area is a lot bigger than what we expect it to be. So what's the cost of supporting all of these options? Some facts. TextDecoder using string decoder. So when you go to Node.js documentation, you will see that there's a module called string decoder that no one literally uses unless they use TextDecoder or TextDecoder. String decoder uses ICU, and ICU is slow. This is a fact. It takes 80 megabytes of Node.js binary just to ship an ICU, and every little small applications that you have, Safari, Chrome, they all deduplicate this data. And so you have maybe a 1 gig of ICU on your machine, only storing that. So let's optimize for common people, not for the spec. Just today, I was having a discussion about optimizing for spec, so this is kind of like a funny coincidence. So let's define what the common use case is. We have a text decoder. It takes a UTF-8 value, fatal true, because fatal is true by default, and ignore bomb. We almost never care about bomb, so it's false. So as a part of this optimization area, we have a fast path. So by default, the text decoder doesn't care about if it's UTF-8 or not, but most people use UTF-8 data. They don't use UTF-16 little endian, UTF-16 bigger endian. They use it with UTF-8. So we add a particular fast path for UTF-8 so that decoding UTF-8 is a lot faster compared to others. This is done by avoiding initialization of ICU because we no longer need ICU for operating. But in other encoding types, if you initialize text encoder or text decoder, it creates a ICU instance, which is a string decoder instance beneath that. So if we lazy load it, meaning that if you see this prepare converter function, this is called only if the value is not a UTF-8 value. So this is a one small fast path to it. So text decoder is not the only place where we can do similar things, meaning that we need to cut corners in order to go for success. Because the success is not a single path, the success changes from people to people. So even in Buffer.byteLength, we have this particular example, which is if it's going for UTF-8, calculating byte length of UTF-8 is a lot faster than calculating it for any other thing. Also, if the encoding is ASCII, for example, you just return the length because that's what ASCII is. But if you don't have this particular path and if you call byte length, ASCII byte length would be a lot more slower than what it is right now. We even have this example of buffer swap 16, where if the buffer length is less than 128 characters, you are just going to calculate it inside this function, just as you see right now. And if it's longer than that, then you call a C++ function inside Node.js. So this is the same exact implementation in two different places, but you call one in JavaScript and one in C++ according to the size of it. We have one more of it, so this slide is particularly important because these kinds of optimizations does not only exist on JavaScript, but also exist on C++ and other languages as well. So the power that you get from these optimizations is not language specific, but it's agnostic. If the input is bigger than 128, then we call a simUTF, which uses CPU instructions specific to your CPU. And if not, then we use the naive way and calculate and iterate the whole array one by one. So I guess it's time to wrap up. I hope you like my lightning talk of 9 minutes and about optimizing live Node.js and unfortunately my kit. Thank you for listening.
Thank you, Yagiz. Let's go over here and have a quick round of questions. The first one, which Ada is named after the other Ada?
My daughter is named after Ada Lovelace, which is the first female French programmer in the world. And Ada programming language is named after Ada Lovelace, so hence Ada. And Ada means island in Turkish language, so we wanted her to be as confident and as free as possible. So, yeah.
How does adding dedicated paths impact long-term maintenance?
So adding specific paths for specific inputs, if you have a test, if you have a really good test coverage, it doesn't really impact. It's a trade-off though. You need to select maintenance, speed, and I forgot the third thing, but like it's a trade-off. For me, especially in this current era, performance is much more important than maintenance, and it's a decision that we take as Node.js contributors take. So we will see in a couple of years, I guess.
What's the biggest optimization you've made in Node?
Biggest optimization having like the biggest impact, probably URL, because URL is used in ESM modules in almost everywhere. And even if you call a single fetch function, it calls URL 8 times. So I can easily say URL, and it's currently the fastest one in the world. So yeah.
Well, thank you, Yagiz. Thanks so much. And thank you for all the questions. Let's give him a round of applause.